Hello everyone, I am Karthik Gurjar. Today I will be presenting the solution for our internal test analysis, specifically focused on normalization techniques in question 13 and 14. This presentation is submitted to Dr. Shaligram Prajapat sir. Normalization is a crucial step in data preprocessing to ensure fair comparison between different data points. Moving on to our first slide, the data problem. Let's dive into question 14. We are given a data set of faculty workload values. Hours per semester 200, 300, 400, 600, and 1000. Before we can normalize, we calculate the essential statistics where count and equal 5, minimum equal 200, maximum equal 5, maximum equal 100, mean is 500, standard deviation is approximately 28, 282.8, mean absolute deviation is 240. These figures are the building blocks for the formula we are about to use. Mean and max normalization. The first method in mean max normalization, this scales all values to a fixed range between 0 and 1. The formula, we subtract the minimum 200 from the value and divide by the range max minus mean, which is 800. The result 200 becomes 0.00, the baseline 600 becomes 0.50, exactly halfway, and 1000 becomes 1, the peak. This method is great for preserving relationship but is very sensitive to outliers. Z-score normalization. The second method is Z-score normalization, also known as zero mean normalization. This tells us how many standard deviations a value is away from the mean. The formula, we subtract the mean 500 and divide by the standard deviation 282.8. The result become 200 become minus 1.06. The mean 500, if it were in the set, would be 0. 100,000 become 1.77. This method is essential when the minimum and maximum of the data sets are unknown. Now the next one, z scores with mean absolute deviation. The third method is z-score normalization using mean absolute deviation. This is a robust variation designed to handle outliers better than the standard deviation methods. The formula the formula we subtract the mean 500 but divide by the mean absolute deviation, which is 240. The result become 200 become minus 1.25. 1000 become 2.08 because the mean absolute deviation 240 is smaller than the standard deviation. The result scores are slightly spread out more. Summary for normalization. Mean max gives us a neat 0 to 1 range. Z scores enters the data around 0. Decimal scaling. The fourth column simply moves the decimal point to ensure all values are less than 1, dividing by 10,000 in this case, resulting in values like 0.02 and 0.10. Comparing this column shows how the choice of technique changes the numerical representation of the same underlying data. Key takeaways are: selection matters. You must choose your method based on your data. If you have bounded data, use mean max. If you have outliers, use z-scores with mean absolute deviation. Impact. Proper normalization allows algorithms like neural network or clustering to converge faster and perform accurately. Third, sensitivity. Always remember that mean max is sensitive to outliers, while z-scores methods offer great robustness. Thank you for listening.